Okay, question 1. 4 descriptions of stages in the program development lifecycle are shown. So we've got 4 descriptions here. Draw one line to link each description to its most appropriate program development lifecycle stage. Not all program development lifecycle stages will be used, so we've got 5 of these to match to the 4 of these. Let's change the pen color. Okay, so let's have a look. Develop an algorithm to solve the problem by using structure diagrams. Detect and fix the errors. Identify the problem and its requirements. Write and implement the instructions to solve the problem. So first of all, 2 of those jump right out. Detecting and fixing errors. Well, if I look down here, there is only one that can possibly be that, and that is testing. So that's one strategy for this type of question, is to just look for things that jump out as being correct. Also, this bottom one here, write and implement the instructions to solve the problem. That's just writing your program, or in this case coding. So that leaves us with 2 to figure out. Identifying the problem and its requirements, and then we've got develop an algorithm. So this to me suggests that identifying the problem is kind of one of the first things that you need to do, and looking at the response we've got left is analysis, design and evaluation. Well, evaluation, as you know, is one of the last things you do, and you can't design something until you've analysed it. So identify the problem and its requirements must be analysis up here. So that leaves us finally with this one, develop an algorithm to solve the problem using structure diagrams, flowcharts or pseudocode. So we kind of develop the problem before we write the program, and the evaluation is the last thing that we do. So this must be part of the design, and you'll probably recognize structure diagrams, flowcharts, pseudocode as things that you use when you're designing something. So we've got that, and you can see there's kind of a strategy to this sort of question anyway, even if you're not 100% sure of the answers. Part B, identify 3 of the component parts after a problem has been decomposed. So when you decompose something, you break it down into smaller parts. That makes it easier to solve. And one of the things that for any sort of computer system is, if I've got space, sort of a little block diagram, which is useful for answering this question and any sort of question on a system, is we kind of need to have inputs which go into our system. Then we will have some sort of processing. Okay, apologies for not so neat handwriting here. We have processing, then we will have, from our processing we'll have output. But usually to process something, we're either going to need to store data, or we're going to need to compare the input that we're processing with something that's stored. So we will have some kind of stored data or storage, and that's going to go like that. So if you just remember that block diagram, that's any system at all. So through the component parts, we basically any of these. So we've got we can have input data, we can have output data, and processing, or information to be processed, or data to be processed. I'm just going to write processing needs or requirements. You could also have information to be stored as well. Let's have a quick look at the mark scheme for this one. So I'm pretty happy with the first one, so there's 4 nice marks for that. And for the next one, they've got inputs, what is input to the system, or what is printed system processes, actions taken to achieve a result, so processing needs, outputs, what's taken out of the system or output data, and they've got storage, what needs to be kept for future use, or the data to be stored is a requirement. Okay, thank you very much. On to the next question.